Now we are at question 4 in tutorial sheet 3, and this question says, venture capitalist Sarah purchases two firms to produce widgets. Each firm produces identical products and each has a production function given by this equation here. The firms differ in the amount of capital each has. In particular, firm 1 has a capital equal 25 and firm 2 has capital equal 100. The marginal product of labor for firm 1 is given by this equation here, and then this equation here for firm 2. Rental rates for capital and labor are equal to 1. Part A of the question says, if Sarah wishes to minimize short-run total costs of widget production, how would output be allocated between the two firms? Therefore, to minimize costs, Sarah should equate the marginal productivity of labor in each plant. If labor were more productive in one plant than the other, costs could be lowered by moving workers across to that plant. We need to set MPL1 equal to MPL2. Therefore, 5 over 2 times the square root of L1 is equal to 5 over the square root of L2. So 5 times the square root of L2 is equal to 10 times the square root of L1 just by cross multiplying. And therefore, the square root of L2 is equal to 2 times the square root of L1. And if you square both sides, you will get that L2 is equal to 4 L1. Let's just come across here. We know that for firm 1, it will be the square root of K1 L1. Therefore, this is square root of 25 times L1. Therefore, Q1 is equal to 5 times the square root of L1. Now, for firm 2, so Q2 is equal to the square root of K2 L2, which is equal to the square root of 100 times L2. Therefore, this is equal to 10 times the square root of L2. But we know that L2 is equal to 4 L1. Therefore, Q2 is equal to 10 times the square root of 4 L1. Therefore, Q2 is equal to 20 times the square root of L1. Now, if we compare Q2 to Q1, we would see that Q2 is 4 times of Q1. So Q2 is equal to 4 Q1. Because Q2 is 20 times the square root of L1 and Q1 is 5 times the square root of L1, so Q2 is 4 times larger. And that answers this question, because this question asks, how would output be allocated between the two firms? Well, the output would be allocated such that the amount of output dedicated to firm 2 would be 4 times higher than the amount of output dedicated to firm 1. So part B says, given that output is optimally allocated between the two firms, so that means that the output of firm 2 is 4 times higher than the output of firm 1, calculate short-run total and average cost curves. What is the marginal cost of the 100 widget, the 125th widget, and the 200 widget? We must know that the short-run total cost is equal to the short-run total cost of firm 1 plus the short-run total cost of firm 2. So let's check firm 1 first. Short-run total cost of firm 1, usually the formula is V, the rental rate of capital times the amount of capital plus the wage for labor times the amount of labor. So therefore, we know V and W is equal to 1, and we know capital is equal to 25. So this is equal to 25 plus L, because W is equal to 1. From the previous equation, we saw that, just do it across here, Q1 is equal to 5 times the square root of L1. So if we solve for L, we get the square root of L1 is equal to Q1 over 5. Therefore, L1 is equal to Q1 squared over 25. Therefore, your short-run total cost for firm 1 is equal to 25 plus Q1 squared over 25. For firm 2, we'll do the same thing. The short-run total cost for firm 2 is equal to 100, which is capital, plus L2. And we know L2 is equal to 4 L1. So therefore, L2 is equal to 4 Q1 squared divided by 25. Therefore, the short-run total cost of firm 2 is equal to 100 plus 4 Q1 squared divided by 25. So therefore, the total cost now will be short-run total cost of firm 1 plus the short-run total cost of firm 2. And so this is equal to 125 plus 5 Q1 squared over 25. And this can be simplified to be Q1 squared over 25. But this short-run total cost is in terms of Q1. We want to put it in terms of Q, some value Q, that would represent the output for both firms. The total output, Q, would be the output from firm 1 plus the output from firm 2. And we know that firm 2, we know that Q2 is equal to 4Q1, which we saw here. Q2 is equal to 4Q1. So therefore, Q is equal to Q1 plus 4Q1, which is equal to 5Q1. Therefore, we can say that Q1 is equal to Q divided by 5. Our short run total cost, which we just calculated to be 125 plus Q1 squared over 5, this is now equal to 125 plus Q over 5 squared divided by 5, because remember we said Q1 is equal to Q over 5. So Q over 5 squared divided by 5, and therefore this is equal to 125 plus Q squared divided by 125. Now let's calculate the average cost. So the average cost is equal to the short run total cost divided by Q, which is equal to 125 divided by Q plus Q over 125. So this is your average cost, and your marginal cost is the differential of your total cost. So this will be 2Q divided by 125. This is your marginal cost. Now the question also says to calculate the marginal cost for the 100 widget, the 125th widget, and the 200 widget. The marginal cost for the 100 widget would be 2 times 100 divided by 125, which would equal to $1.60. The marginal cost for the 125th widget would equal to 2 times 125 divided by 125. This would cancel out, and therefore you should get $2. And the marginal cost for the 200 widget would equal to 2 times 200 divided by 125, and this would be $3.20. And that answers part B of the question. So part C says, how should Sarah allocate widget production between the two firms in the long run? Calculate the long run total and average cost curve for widget production. Well, in the long run, because of constant return to scale, then we can change capital so that it doesn't matter where the production occurs. It could either split evenly or produce all in one plant. In the long run also, the firm will operate at the minimum average cost. There are two ways to calculate the minimum average cost. We could either take the differential, set it to 0, and solve for the minimum quantity, or we know that the marginal cost curve would cut the average cost curve at its minimum point. So we can just set the marginal cost equal to the average cost and calculate for the minimum quantity. So I will do that method. We know that the marginal cost is equal to 2Q over 125, and we know that the average cost is equal to 125 divided by Q plus Q over 125. Therefore, we just need to set the marginal cost equal to the average cost, and we would get 2Q over 125 equal 125 divided by Q plus Q over 125. You carry this across to the other side, and so you get Q over 125 equal to 125 divided by Q. You cross multiply, and you get Q squared is equal to 125 squared. Therefore, Q is equal to 125. Therefore, at Q equal 125, we get the minimum average cost. But what is that minimum average cost? Well, the minimum average cost would be when Q is 125, and therefore this is equal to 125 divided by 125 plus 125 over 125. Remember, because this was Q and this was Q here. Therefore, this is equal to 1 plus 1, which is just equal to 2. Therefore, your average cost in the long run would equal to 2. And let's check our marginal cost in the long run. Our marginal cost would also equal to 2. The marginal cost we know is equal to 2Q over 125. Therefore, this is 2 times 125, because Q is 125 in this case, divided by 125, this would cancel out, and so we end up with 2. Therefore, in the long run, your marginal cost is equal to your average cost, which is equal to 2. Now, also, we know, I'll just write it in the small corner here, we know that your average cost is equal to your total cost divided by Q. Therefore, your total cost is equal to your average cost times Q. Therefore, we can say that total cost is equal to the average cost times Q, which is equal to 2Q in the long run. And that answers part C of the question. Now part D of the question says, how would your answer to part C change if both firms exhibit diminishing returns to scale? If there were decreasing returns to scale, then we should let each firm have equal share of production. The average cost and the marginal cost would not be constant anymore, and they are now increasing functions of Q. So we do not want any one plant, to be too large. Basically, if there's decreasing returns to scale, it means that as output increases, your total cost would increase more than proportionally. So you would try as much as possible to not have any one firm producing way too much. So the best way to minimize your production in either firm is to share the production equally between two firms so that your production in one firm won't be way too high and thus increase your total cost. So that answers that question. And that's it for this question. Thank you for watching, and I'll see you in the next one. Goodbye.